Hey everybody, it's Nick from First Coast Math Clinic. In this video, I'm going to show you how to identify systems of equations with no or infinite solutions on the coordinate plane. Let's get into it. So for the two examples in this video, we're going to first identify if the systems have no solution or an infinite number of solutions using what we figured out in the previous video, and there's links to that video at the end of this video. Then we're going to graph the system and see what does that system look like on the coordinate plane. What conclusion can we make about what a system looks like on the coordinate plane if it has no solution or an infinite number of solutions? So let's start with number one. And I'm going to start by just writing these systems in slope-intercept form. So let's get y by itself. I'm going to add 3, add 3x. 3y equals 3x minus 12. Divide by 3, 3, and 3. So y equals 1x minus 4. So this top equation is y equals 1x minus 4. And my bottom equation, negative x plus y equals 3. Let's add x. X's cancel out. We get y equals x plus 3. All right, so what do we notice about this? Well, we notice that our slope for both of these are 1 and 1. And from the previous video, we know that if our equation in slope-intercept form have the same slope, we're going to have no solution. So we have the same slope, so we're going to have no solution. So let's see what these look like on the coordinate plane, starting with this top equation, and see exactly why. Well, why do we have no solution if we have the same slope? So let's graph that in red. I'm going to start at negative 4 on the y-axis. 1, 2, 3, 4. My slope, I'm going up 1 over 1, up 1 over 1. So this is my graph for y equals 1x minus 4. And then let's do this second one in blue. So y equals x plus 3. So we're going to start at 3 on the y-axis. 1, 2, 3. And then here we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And we notice that no matter how far we go, right, these two lines, even if we continue this towards the left, and then do the same thing with our other line, our y equals 1x minus 4, continue to the left, our lines are simply, they're not going to intersect, right? So these lines are going to be parallel to each other. They have no point of intersection. So on the graph, when we see something like this, we know we have no solution as well. So that's what these lines look like. The system looks like on the coordinate plane. We're going to have a set of parallel lines that don't intersect and have no solution. All right, let's look at what a graph of systems with an infinite number of solutions look like. So for our second system, if we try to use maybe elimination to solve this, let's say we want to get rid of that x value. So let's just identify first that we're going to have an infinite number of solutions here. So let's multiply by 2 and 2 because we want opposite coefficients for that x value. Our new system is going to be 4x plus 10y equals 20, and then negative 4x minus 10y equals negative 20. Our next step, add, and then everything basically cancels out. We get 0 equals 0, which still is a true statement since the left side and the right side are equal to each other. That means any value we put in for x and y is going to be true, so we have an infinite number of solutions. So let's see what that looks like on the coordinate plane. So let's graph these equations. I'll start with 2x plus 5y equals 10. Let's write this in slope-intercept form. So I'm going to subtract the 2x, 5y equals negative 2x plus 10, divide by 5, 5, and 5. So we get y equals negative 2 over 5, x plus 2. So this top equation, negative 2 over 5, x plus 2. And this bottom equation, negative 4x minus 10y equals negative 20. Let's add 4x, add 4x. 4x's cancel out. Negative 10y equals 4x minus 20, divide by negative 10, negative 10, and negative 10. So do this up here. The negative 10s cancel out. We get y equals negative 4 over 10 x plus negative 20 divided by negative 10 is going to give us a positive 2. So let's simplify this negative 4 over 10. We know that, well, this is 4 is 2 times 2, 10 is 2 times 5. Cancel out the 2's and we get 2 over 5. So we can simplify this to negative 2 over 5 x plus 2. So we wind up getting the exact same equation, right? So if we graph these, up 2, start 2 on the y-axis, then to graph this, we're going to go down 2 over 1, 2, 3, 4, 5. And we get the exact same equation, exact same graph for both of these. All right. So that's what the graphs of systems with an infinite number of solutions will look like. We basically have the same equation and we have the same graph. This video was on identifying graphs of systems of equations with infinite solutions or no solutions. I hope this video helped you understand that concept a little bit more. There's a link to another video on systems of equations with infinite or no solutions. If you want to review that, you can check that video out. It should be coming up right now. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.